Hello my dear friends, welcome to the quickest, the sharpest, the easiest, simple subject. Welcome to mathematics. Friends, in our previous video we saw decimal representation of a rational number. Today we are going to see irrational number. So before seeing irrational number, let's recall Pythagoras theorem. Students, we know that in Pythagoras theorem, we know that Pythagoras theorem is applicable to right angle triangle only. Suppose ABC is a right angle triangle and angle B is a 90-degree angle. Angle B is 90-degree angle. So naturally this AC, side opposite to right angle, is called as hypotenuse. And Pythagoras theorem is this hypotenuse square. H square is equals to base square plus height square. Okay students, now suppose I'll make a small table and we will fill the values in that table. Suppose base is given, height is given, and we have to find out hypotenuse. Okay students, suppose base is 3, height is 4. Then what will be the hypotenuse? Hypotenuse will be equals to, hypotenuse square is equal to base square plus height square, means 3 square plus 4 square, which is equals to 9 plus 16 equals to 25. Hypotenuse square is equal to 25. Hypotenuse is equal to root 25, which is equals to 5. So hypotenuse will be equals to 5. Got it students? Now this 25 is a perfect square number. What do you mean by perfect square number? A number which square root is a natural number, like this 5. Okay students, let us see one more example. Second example. Consider as base is equals to 12 and height is equals to 5. What will be the hypotenuse? Once again, according to the Pythagoras theorem, hypotenuse square is equal to base square plus height square. Let's replace the values. Base is equal to 12. So 12 square plus 5 square, which is equals to 144 plus 25, which is equals to 169. Hypotenuse square is equal to 169 and hypotenuse is equal to square root of 169. And is it possible to find out square root of 169? The answer is yes, and the square root is equals to 30. Okay students, so here hypotenuse is equal to 30. But let's consider third example where the square number is not a perfect square. Means square root is not a natural number like this 5 or 30. Suppose your base given is equals to 1, height is equals to 2, then what will be the hypotenuse? Let's replace the values students. Hypotenuse square is equal to base square plus height square, which is equal to 1 square plus 2 square, which is equals to 1 plus 4, which is equals to 5. 5 is what? Square of hypotenuse. What is 5? Is it hypotenuse or square of hypotenuse? It is nothing but the square of hypotenuse. As in this example, 25 is the square of hypotenuse. In this example, 169 is the square of hypotenuse. In this example, 5 is the square of hypotenuse. Then what will be the hypotenuse? To find out the hypotenuse, in this example we find out square root of 25. In this example we find out square root of 169. So in this example we have to find out square root of 5. So hypotenuse is equal to root 5. What is the hypotenuse? It is nothing but root 5. Why I have written root 5? Because this 5 is not a perfect square. We cannot find its square root as a natural number as we have done in these two examples. Okay students, this root 5 is called as an irrational number. This root 5 is called as an irrational number. Okay students, so in this video we are going to see various such kind of irrational numbers. Suppose your base is equals to 2 and height is equals to 4. Then what will be the hypotenuse? Let us try to solve it. Fourth example. Once again, hypotenuse square is equal to base square plus height square, which is equals to 2 square plus 4 square, 4 plus 16, 20. 20 is nothing but the square of the hypotenuse. Therefore, hypotenuse is equal to root 20. So what will be the hypotenuse? Hypotenuse is nothing but root 20 in this example. Okay students, now consider I want a specific value as an hypotenuse. Here I want a specific value as an hypotenuse. For example, I want root 13 as hypotenuse. What do I want? Root 13 as a hypotenuse. So what I have to do? I have to adjust two numbers such that their addition of their square is equals to 13. To find out root 13 as hypotenuse, what I have to do? I have to add two numbers, square of two numbers, such that addition of their square is equals to 13. Because in this example, addition of the square is 5. In this example, addition of the square is 20. So here square root is root 5. Here square root is root 20. And what do we want? We want square root is equals to root 13. So we have to find two such numbers as their addition of their square is equals to 13. Let's try to find out. So for that, what we have to do? Let's see various combination of 13. 13 is equal to 1 plus 12. Now this 1 is a square of 1, but 12 is not square of anything. And what do we want? We want addition of squares, not only addition of numbers. We want addition of squares. This is a square, this is not a square. So definitely this 13 is not addition of squares. It's simply addition of two numbers. Let us see second combination, 2 plus 11. Now 2 is not a square, 11 is also not a square. So here 2 plus 11 is addition of two simple numbers. It's not addition of squares. Let us see third, 3 plus 10. 3 and 10 both are not squares. So in this case also it's not addition of squares. 4 plus 9. Look at this example. Look at this case. 13 is equal to 4 plus 9. 4. Is it a square of any number? Yes. 4 is square of 2. 3. Is it a square of any number? Yes. 9. Is it a square of any number? Yes. 9 is square of 3. So this 4 plus 9 is equal to 13. In this case, 13 is nothing but addition of squares of two numbers. Got it? And which two numbers are they? This is nothing but the square of 2 and this is nothing but the square of 3. So 13 is equal to 2 square plus 3 square. Means in Pythagoras triangle, suppose we have base is equal to 2 and height is equals to 3. Then hypotenuse will be equals to root 13. Let us see how. This is our fifth example. Hypotenuse square is equal to base square plus height square. Once again students, 13 can be, there are various combination of 13s. 1 plus 12, 2 plus 11, 3 plus 10, 4 plus 9, 5 plus 8, 6 plus 7. Lot of such examples, combinations. But why are we taking 4 plus 9? Because we want this 13 as addition of squares of two numbers, and 4 is a square of one number, 9 is also square of another number. So this 13, 4 plus 9 is nothing but addition of squares of two numbers. So here we are doing addition of square of 2 plus square of 3. So it is equals to 4 plus 9, which is equals to 13. Hypotenuse square is equals to 13. Therefore, hypotenuse is equal to root 13. Got it, students? Let us see the final example. Sixth one. This section I am keeping as rough sections. I will have a heading as rough. Okay. So 2 and 3. Let us see the final example. Suppose I want hypotenuse is equals to root 41. We want 41 as addition of two square numbers. Let's try to find out a combination where 41 is the addition of two such numbers. 41 is equals to 1 plus 40. Here it is not addition of square of two numbers. 1 is definitely a square of 1, but 40 is not square of any number. So this is useless. 2 plus 39, both are not square numbers. 3 plus 38, both are not square numbers. 4 is the square, right? 4 is the square, but 4 plus 37. Here 37 is not a square, right, students? 37 is not a square, so we cannot write this combination at all. Let us see next. 5 plus 36. Here 36 is the square of 6, but 5 is not square of any number. Let's move forward. 6 plus 35. 6 and 35, both are not square of any number. 7 plus 34, both are not square numbers. So here 34 plus 7 is not addition of square numbers. 8 plus 33, 9 plus 32. 9 is a square, but 32 is not a square, and we want addition of two squares, not one square number, okay, and another non-square number. So 10 plus 31, both are not square. 11 plus 30, both are not square. 12 plus 29, both are not squares. 13 plus 28, 14 plus 27, 15 plus 26. All these are not addition of squares. 16 plus 25. Here 16 and 25, both are square numbers. 16 is the square of 4 and 25 is square of 5. Means in this case 41, 16 plus 25 is equals to 41. In this case 41 is the addition of squares of two numbers. Here 41 is the addition of square of 4 and square of 5. Means if the base is equals to 4 and height is equals to 5, hypotenuse will be equals to root 41. Let us see how. According to Pythagoras theorem, hypotenuse square is equal to base square plus height square. Right, students? Suppose base square is equals to 16. Base square is 16. Means what will be base? Base is equals to 4. 4 square. Height square is equal to 25. So what will be the height? Height is equals to 5. Square of height is 25. So height will be 5 because square of 5 is 25. So here it will be 16 plus 25, which is equals to 41. Hypotenuse square is equal to 41. Therefore, hypotenuse is equal to root 41. So if base is equal to 4 and height is equals to 5, hypotenuse will be equals to root 41. So students, to find out such irrational number, we have to follow two steps only. First, look for the given number and find out combination of addition of such numbers that both of the numbers are perfect square numbers. As in this example, 1 plus 4, 1 is square of 1, 4 is square of 2. In this example, 4 plus 16, as 4 is square of 2 and 16 is square of 4. So we have to find out two such numbers, two perfect square numbers, and write their addition in such form. Got it, students? So to find out such kind of irrational numbers, what we have to do? We have to find out the given number as addition of two perfect square numbers. And for that we have to check such kind of combination. Students, please, this much part is a rough part. I will have a border around it, ugly border. Don't laugh at my drawing. It's my right to laugh at it. Okay, students, so this much part is rough work. So we have learned 6 examples to find out various irrational numbers. Thank you, students.